Hello and welcome back. During this segment, we're going to be comparing infrared heaters with each other. As you have probably noticed, there are many different brands and varieties and types of infrared heaters. We're going to show you some of the comparisons as we go through them here. Now, as you see, what we've done is we've marked all the heaters on this side with yellow signs, and this here is the heat output of the infrared heater. Over here we have the green ones. These are a little bit hotter. Now, when we check the heat output of an infrared heater to be consistent, what we do is we measure the hottest point. The hottest point of an infrared heater where the heat comes out is the top center. We use a laser thermometer to check that point. When we compare the heat output, there are three main things we look for. One is the temperature of the heat coming out. How hot is it? Second is volume. How big is the opening that's allowing the heat to come out? And third is the speed. How fast is the air coming out? Well, what we have is this little gadget here that checks the speed of the heat coming out. And out of all the infrared heaters that we've tested, our heater comes out at the fastest speed out of all of them. So we know it's coming out faster than any of them. The opening is relatively the same with all 1500 watt infrared heaters. Some of them may be more narrow, some may be more wide, but the cubic inches is pretty much the same from one to the other. So the biggest variable would be the heat output. Now, when you check the heat output of an infrared heater, what we do to test them, the top center is the hottest point of an infrared heater. So to use that as a benchmark, as we test all the different infrared heaters, that's where we'll be putting the laser thermometer. Now, the laser thermometer is might be a little bit difficult for you to see there, but we'll do our best, and there will be two numbers. The top number is the current temperature, and the bottom number is the hottest temperature during that reading. So let's see if we can't get that. We'll put that there, you see. Now the top number is going to keep changing because it'll keep changing as the laser dot moves within there. The bottom number is the hottest point that it reached. So if you can see that, it's actually 603 degrees. This one here is 600 degrees, and that's the white sign. Then the yellow signs are all 200 degrees and lower, and the green signs are over 200 degrees but under 400 degrees. As we compare the heat output of infrared heaters, we use these guns. They're laser thermometers, and you can see they're actually two different ones. And the reason I want to show this to you is if you decide to go out on your own and buy one of these and test them, the results may be a little bit different. They will vary from one gun to another. So what we do is we use the same gun whenever we test all the heaters to make sure the heat output is the same. So now in testing the heat output, again, the top center is the hottest point. And what we're going to do is we're going to look at this one here, and we're going to get the hottest point on this, the top center. And if we hit it just right, we should be able to get close to 200 degrees. We're 197. We're getting close. So there we go, 201. Okay, 200. So 200 degrees is about the hottest point you're going to get on this particular heater. And you can see the thermostat is set all the way on high, and that's the most heat that it's going to make. So if we compare that with our heater, okay, and we'll do the same thing, and we'll put it to the top there to get the hottest point. And the hottest point on this one is just over 600. There you go, 609 degrees. If you can see the bottom number there. Now let's go compare a couple other of the heaters that we have. Let's try this one here. Okay, the top center. Okay, now this one's actually up to 400 degrees. All right, so let's try this one here next. Try to get the hottest point. There we go, 290. Okay. 300. Okay, we got this one all the way up to 300 degrees. All right? The hottest point. Another way to check is what I call a hand test. It's not quite as scientific as your more expensive laser thermometers, but it's equally as effective. And what you can do is you hold your hand up there, hold it vertically flat, touch the heater at the top and the bottom, and see how many seconds you can hold your hand there. With my heater, after about 9 seconds, you have to pull your hand away. It gets too hot. With other heaters, you do the same thing and you hold it there, and you'll be able to hold it there much longer. In some cases, you can hold it there twice as long, or even 3 times as long. Some of these heaters over here on this side, you can actually hold your hand there almost an entire minute before it gets so hot you need to pull your hand away. So how long you can hold your hand there will determine how hot it is and how much hot air is actually coming out. And you'll find with our heater, it's the shortest time that you'll have out of all the heaters that you test. So there's a test you can do at home. If you already have an infrared heater and you decide you want to go ahead and buy the best one made, you go ahead and buy the best one made and do that simple test at home and you'll be convinced. So what we do by looking at the speed of the air coming out, the volume of air and the temperature coming out, and also through real life testing, we can put square footage as to what area each heater can heat. So these here with the yellow signs, these here you would need 2 of these heaters to make as much heat as 1 of these. This heater here makes twice as much heat as these here do. Now when you look at the temperature, you might say, well, this is 200 degrees, this is 600 degrees, so therefore you would think this makes 3 times more heat. But you need to factor in the air flow. It is coming out faster, but it's not coming out 3 times faster than these are. So to be fair, you would need just 2 of these to make as much heat as 1 of these. If we look at these here, you would need about 1.5 of these to make as much heat as 1 of these. Another way to say it is that this heater makes 100% more heat than these heaters do. Or this heater makes 50% more heat than these heaters do. And they all use the same amount of electricity. They're all 1500 watt heaters. Now when checking the electric consumption of an infrared heater, you can use a little gadget, something like this. It's called a watt meter. And what you do is you just simply plug it into an extension cord or an outlet in your home, and you plug a device in it. It can be a refrigerator, television set, whatever, and it'll tell you how much electricity it's actually using. And what we do to test our infrared heaters is we plug each of them into a watt meter. And then it'll tell us how many watts it's using. And very few of them are exactly 1500 watts. This one here has a tendency to run around 1400 watts. There are some that run a little over. This one here runs a little bit over 1500 watts. Some of these on this side here, they only run maybe 1300 watts, 1350 watts. They'll vary from one to another. Another thing that we found is that, I don't want to be too technical, but with a circuit breaker, it depends on what pole an outlet in your home is actually on. One outlet could be on one pole in your breaker, another outlet could be on a different pole. And so the amount of draw at any given time could change the actual wattage output. So if you use a watt meter, again, they're not exactly precise. Even within our test facility here, we can plug an infrared heater into an outlet and see how much electric it's using. We can plug another infrared heater into a different outlet, and that will change the actual reading as to how much electric this heater is drawing just by plugging another one in a different outlet. So they're not exact, but what we do is we use the exact same outlet when we do our testing. That keeps it consistent with all of them. All right? But the heat output is the main thing you're looking for, and without question, it makes more heat than any other 1500 watt infrared heater made, which means it's going to cost you less in electricity. You may be able to buy one of these infrared heaters for $99 at Walmart, but your electric consumption is going to be $500 more. It'll be $1,000 a year to heat 2,000 square feet. It'll only be $500 to heat with this. So in the long run, you're not saving anything by getting one of these more expensive ones. The truth of the matter is, if you could get one of these for free, it still is going to cost you way more than heating your home with this, simply because of what you'll save in electricity.